There you go.
Well, welcome to the, what day? August 9th, 2022 session of Tangerine SDR and Hampside technical session.
I think it's the
Right.
8th.
It's the 8th, not UTC.
Right.
And my name is Dave, KB0S, and this week I've been dealing with family health problems mostly, and so I haven't done a whole lot. Anyway, that's it for me. And next on the list is Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thanks, Dave. Things are going fine here. I've been continuing to work on some of the code for doing grape data analysis. So that's coming along. There were some bugs in this code I had that would overlay nighttime on top of the plots, like a night shading. Got that figured out. So I'm continuing to work on that. Let's see. I also worked with Scotty and Steve Bible and Dave Larson. I sent you guys a message where I sent out what I think the talks will be for Tapper and for Hampside. So I'm working with Steve and Scotty and getting that all scheduled. So going along with that, back to net.
Very good. Next on the list is Dave, KD0 EAG. Go ahead, Dave.
Well, as I was saying, I have been working mostly on trying to get a once and for all release of the run mag that suits all the use cases. And I have currently put some code up on the GitHub for that, and that's marked as version 1.2 or something of that sort. And it mostly fixes things that shouldn't be too troubling to most users of the 1.1 code. But if you're not using CSV output and not using, not experimenting with the cycle count registers, but I did fix those things to be more general. At least I think I fixed them. At one point I thought I had made them much, much worse, but I think what's up there, but somebody will tell me different, I'm sure. So that's probably my main adventure, plus trying to replace some of the equipment that's been failing around here, which has occupied some of the last week. That's it for me. Thanks.
Very, very good. Next on the list is Jules, K2 KGJ. Go ahead, Jules.
Okay, well, this week I was batching it as my wife and one of our grandsons is in California doing a trip in the San Francisco Marin County area where we used to live. So I expect they'll be back sometime middle of this week. Meanwhile, the dog and I are taking care of things here. As everybody on the East Coast probably knows, we haven't had much in the way of rain, and again, it's another hot, dry day today. Pond is down another foot, which is not good. We really need the rain badly. Been working on the magnetometers this week. Unfortunately, I missed the geomag storm that we just had because both magnetometers were down, one for software change, the other for modification for 1 PPS GPS signal, which is now up and running again. So we'll see. The one thing I'm noticing is that the dual magnetometers I have buried out in the backwoods are both indicating a vertical component of about 46,000 nanoteslas, whereas the one nearest the house, or pardon me, 59,000 out there, the one nearest the house is registering about 46,000 nanoteslas for the vertical. They're both sites are registering the same for the x-axis and for the y-axis. So I'm not sure if I've got a magnetometer problem, but I'm going to probably have to pull one of them and just check that out fairly soon. Back to net.
Well, fine business. And next on the list is Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to the net. Couple of things, continue to run beta testing on the Personal Space Weather Station Network website. So Todd, Christel, and I are both uploading and going through and fixing bugs and putting a few tweaks on with that. Also worked on the NASA project a bit and figured a way to use least squares combined with a sine curve to figure out the period of traveling ionospheric disturbances, and right now putting together a process to automate that whole process, starting with data and ending up with stats on the...
I think we lost you, Bill. Your mic went out.
Change volume.
Yeah.
Let's see. Master volume, any difference
There.
now?
Now you're back.
Yeah, it's just typical Windows. Anyway, so I'm going through and trying to automate that to be able to get stats on the traveling ionospheric disturbances so we can study them and see how they change seasonally and characterize them a little bit better. So back to net.
Well, fine business. Next we have Bob, KC3, looks like QOB. Is that correct, Bob? Unmic your, yeah.
That is correct. I am just here, my first time to observe what's going on. I have been out of the field largely since the late 70s and early 80s. To give you an idea, back then I did a lot of RF work and microwave work. But then I moved on to other things, and now I am a colleague of Nathaniel, and he has gotten me very interested in RF effects again. So that's my story. I don't have any progress on anything to report since.
Well, welcome, and we hope that you find some niche in this project that you like working on.
I'm sorry, I didn't understand that.
Well, I want to welcome you to the group, and I want to hope that you can find some part of the HAMSci project that you find interesting to work on.
I'm sure that will happen. Right now, I'm pretty much looking at everything that looks very interesting and thinking about what little tiny piece I could focus on.
Yes. Well, welcome, and I hope you enjoy the discussion. So next on the list, we have Bob McGuire in for HY. Go ahead, Bob.
Okay, good to see everybody. I'm sitting out in a park. I don't know if you can hear the cicadas or not, but it's awfully pleasant here in the middle of Maryland. I've been working with the folks up at Scranton, including our fearless leader. We're about to kick off an ionoson development project with one of the students up there who I've yet to meet, but things are looking good. Looks like we got a state grant to fund it. And so we're going to add the ionoson to the upcoming eclipse development. And it's a renewal and extension of the ionoson I did at Virginia Tech for the previous solar eclipse in the United States, and we'll apply it to the new one. Of course, the one from previously went from west to east. This one's going north-south, and so it should be interesting. We'll get a lot more concentrated stuff in the country. But what we did was we built a simple to use and easily deployed ionoson that used several frequencies. And this time I'd like to extend it so we have a wideband antenna, and that's going to be using an antenna that's used at Wallops and the Scandinavian countries for ionosons. So Nathaniel has a large field behind his house. It's going to be full of wire. So that's my report for right now. We're just about to get going.
Very good, Bob. Thank you for the report. Next on the list, we have Chong, KC3UAX. Go ahead, Chong.
Hello, everyone. Well, I agree with Dr. Spoletta that Dr. Fizell just emits his own very strong gravitational field that just pulls everyone around him into his many projects. Yeah, so this week I've been writing the FPGA code for the SPI controller on the data engine. That's just a very well, that SPI controller allows us to configure the ADC on the dual channel receiver, but there's been a slight inconvenience because the ADC was made by Analog Devices and they are using a pretty odd variant of the SPI's protocol. SPI protocol allows us.
Sorry about that.
Oh, are you familiar with it?
Yes, I used to work for Analog.
Oh, okay, yeah. So yeah, it's a protocol. It's a serial protocol. It's relatively fast actually, but most SPI protocols use two separate lines for output and input. However, Analog Devices combines them both into one. So now it's I don't know if I can even call it SPI anymore, but yeah, I gotta deal with it now. Back to the net.
Okay, well, thanks for that. And next on the list is David in one HAC. So you can comment, David.
Yeah, sorry that every designer seemed to want to do a different SPI interface, and that one sounds like a combination of SPI and I2C. Probably doesn't implement either one of them quite right, but oh well, deal with it. They're good parts otherwise. Yeah, my thing is this week is I'm deep into RFI testing of a solar and wind power system that will ultimately send down to Antarctica and presumably have a sounder attached to it. So got to keep it quiet. Nathaniel, you do know that the Virginia Tech antenna has a 100-foot mast and it goes 100 feet either way too.
Which one is that?
Their transmitting antenna.
In Blacksburg?
I thought, oh, maybe I'm thinking of the Lowell one. But if you're talking Wallops, the sounder Wallops is a Lowell one, or does Virginia Tech have a different one?
Are you talking about Bob McGuire? Because I wasn't talking about these.
Yeah.
Yeah.
Yeah, Bob was talking about it, but he said something about filling your field with wires.
Well, Bob is developing a different low cost ionoson that would use this other antenna that the one he sent me an article that was actually, I think, written by Terry Bullitt and Justin maybe who I'm sure you know. I can bring it up. So
I'd be interested.
Yeah. Okay. Yeah, I'll bring it up in a second. It's actually a wire log periodic.
Right. Oh, okay.
Yeah, give me a minute and I'll bring it up.
Pointing up, I presume.
Yes, pointing up. That's right.
It's not a big deal when you're sending it.
I'll bring it up in a minute. Keep talking.
Okay. Well, I think that's about it, except that we're getting a number of waves of thunderstorms connected with our hot and humid weather here. You guys down south, you don't have an exclusive on this. We've been 95 to 100 degrees here and extremely humid. So
actually, I think our weather in Alabama has actually been a lot nicer than yours. We haven't had that many days over 95. I mean,
yeah, we're getting sick of it.
It's been nice. I mean, the weather here has been.
That's good.
Normal for us. It hadn't been unusually hot.
Yes.
Yeah.
Yeah, but for us in New Hampshire, this is not
Oh,
our
yeah.
norm.
I mean,
Yes.
we're working on a proposal to air condition the streets next.
Oh, okay. Sounds good.
So,
I think
next,
yeah,
oh,
I think that's it
Nathaniel's
for me.
got his
Here you go.
His
Transmit antennas for
picture.
ionospheric sounding applications. It's Rob Redman. So it's Rob Redman and Terry Bullitt. Transmit
Oh,
antenna.
okay.
And
Could you send me a
yeah,
link to that? Or
sure.
post a link?
And apparently that's what it looks like. This is going to be.
Oh, interesting.
Well, that'll be a lot of wires in your backyard.
But
This
how
is gonna
big
be
are
very-
those towers and what's the spacing? 4 towers of 36 meters.
There you
Yes,
go.
100 feet,
Yep.
76 meters on a side. Like I said,
Wow. Yes. All
yeah, I
right.
know the wavelengths involved, and you need big antenna. I did a sounder way back in the 90s that used the vertical delta, the half delta antenna, half rhombic.
Yeah, I'll send this over to you.
Great, thank you.
You're
Oh,
welcome.
Back to
Okay.
net.
The next person on the list is James, KG4 DSG. Go ahead, James.
Evening, Dave and group. Not much going on here. Just hot and muggy, just as normal. Looking forward to DCC. I'm still trying to make reservations. So back to net.
Next on the list is Joe, W7LUX. Go ahead, Joe.
Thanks, Dave, and good evening, everyone. Oh, just plugging away here. We've the grape receiver is working when I remember to switch all the antenna back and out of null mode. But the antenna is also used for various ARES and RACES nets. But the big problem here has been too much water on the fire scar burn areas. And then we get lots of flooding and all sorts of debris over the highways and streets and into people's homes. And it's just all sorts of unpleasant stuff. And I see where, let's see, Death Valley just about got washed away. That made the news here. They got a huge amount of rain in a very short period of time. So it's being a little bit too much water all at once. We desperately need the water, but could you spread it out just a little wee bit? Anyway, thanks much,
Yes.
Dave.
Yes, I heard some eyewitness reports of that downpour at Death Valley. It was pretty wild. Anyway, next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. It's been a fairly busy week. So I found out the mystery of the strange phase measurement of NAA. Turns out it was something pretty obvious. And Marcus, via the elfgroups.io group, he's very active and very, very knowledgeable about signal processing and radio in general. He's also a very active radio amateur at the ULF frequencies as well. And he was figuring out, what might cause this, and he says that it looks like your NAA plot is either 60 or is either at 60 or at 150 degree phase, but never any intermediate values. And he thought, well, could this be a sample rate issue? So then he goes on to say, for NAA, the reconstructed carriers after frequency doubling are 47.9 kilohertz and 48.1 kilohertz. If your sample rate happens to be exactly 96 kilohertz, the two carriers would be positioned perfectly symmetrical around the Nyquist boundary and thus would be aliased onto one another. He goes on to speculate that this could cancel the quadrature or imaginary component of the signal and reduce the phase information to only the sign of the real part. That would be modulo 180 degrees. After scaling by half to the fundamental frequency, this would produce 90 degree steps. And lo and behold, my sample rate, the audio injector stereo samples at 96 kilohertz. So what Paul and Marcus recommended is to resample at 192K, which I did, and I was able to get proper phase measurements from NAA. However, higher frequency VLF stations, they don't produce, they don't really produce valid data. Paul, I think Paul is working on a fix for VT-SID that I won't have to resample. So that was really cool to learn that. I also finished the hardware interface to my 3-channel VLF system. What I did was I wired everything up and I tested the output of the DC to DC converters. So it's pluggable with pin sockets. You could plug in either a 24 volt DC to DC converter or a 48 volt one if you have a long run of cable. And when I tested the 48 volt DC to DC converter, when I powered it on, I heard some popping sounds. So I immediately unplugged it, and I realized that that when I was looking at the data sheet, I wired the input voltage wrong. So it was getting the wrong polarity. The positive input voltage was going into the negative input pin and vice versa. So once I fixed that, everything worked. So now I have to attach the some short cables to power the Raspberry Pi and the GPS module, and we're good to go. I'm also working on my EBNOT rig. That's also another Raspberry Pi with a GPS. My hope is that I could do a presentation for Tapper about EBNOT to inform hams that there is some really good amateur work at the ULF bands. So I plan on having a working unit for that presentation. Yeah, I'm trying to get that up and working right now. That's all I have. Back to the net.
Very good. And we've already talked to Jules. So next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave. Good evening, everybody. Hopefully my audio is working this time.
Yes.
Not too much this week. I had a good phone call with Kong or Zoom on the data engine, mostly the software architecture and the functionality of what it's supposed to do, and put together a couple of slides on, kind of a list of how we could implement it first for testing hardware, and then, maybe something for the real project a little later on. the Kong was able to successfully build one of the versions of the software, but not the later version. And so I'm trying to figure out what went wrong in the later version that caused it to break. And so I'm going to try to build a version based off the older version, but then backporting all of the more recent changes to it and see if that works and give that a try. I've been playing with it. I found that the tools appear to absolute path code certain things in it. And so when I grep the tree, after I've copied the software to a new directory, there's points of it that are still pointing to the directory it was copied from, rather than the new directory it was copied into. And so not all the paths are relative. Some of the paths are absolute. And that makes it not only difficult to copy a project into a new directory, but on a Linux system, you can't install it on another computer because the user has a different /home/username directory. And so that messes that up. So I'm going through trying to figure out what's going on and what's absolute, and or just to see if I've got a cockpit or some kind. And so that was it for the week. Kong and I talked a little bit about the SPI interface, and he's jumped right on that, and that's great. That's one of the first things we'll have to have working in Verilog before we can test. So that will be super. And so I'm trying to get a new version out, and when I get that, we'll get it to Kong for testing. If he can build that, then we'll have a couple of chunks, and we'll have 2 people able to build partially functional FPGA code. So that'll be a good help. Back to the group.
Very good, Tom. Sounds like progress. So that brings us to the end of the list. So we're open for general discussion.
I was going to make a comment on Jonathan's problem, which was very interesting to realize that NAA at 24 kilohertz is exactly a subharmonic of our sampling frequencies for, generally audio codecs. Very little is done at 44.1 unless you absolutely have to do for CDs. Everything's done at 48, 96, 192. Now we have done NAA work, and I believe we were sampling at 192. So that avoided any of the even second harmonic type problems that he was having. But it was an interesting thing to realize that by doubling the frequency, which is a common thing to do to demodulate these phase modulated signals, or in this case, minimum shift keying, it dumped it up to an aliasing issue at 96 kilohertz. And then it was pointed out that there's a further anomaly that sometime recently, NAA incorporated a very small frequency shift. So it does not stay locked to an atomic reference. It is very slowly changing phase. And so again, if you have some kind of sampling boundary that you can cross, it will do it at some random time, depending upon your frequency versus their frequency. So it was a interesting problem to have come up, but now that the community seems to be aware of it, hopefully it can be avoided. And none of the other stations will have this because they don't have that frequency.
Right. Yeah, this was a really interesting problem, and it was just really cool. But yeah, I believe Paul is working on an update for VTSID to change his method, and this way we won't have that problem again. And an obvious way to fix it would be to sample at a higher frequency, at a higher sampling frequency, and that's where that 192 kilohertz audio injector sound card came in that I was working on. But because of the high sampling rate and because it was a Raspberry Pi 3, it was getting really hot and using up a lot of CPU. So the solution to that would be probably to use a Raspberry Pi 4 and that sound card, and that should fix the problem if you don't want to use a regular PC. But yeah, that was a really cool problem.
So did anyone catch the geomagnetic storm in their data yet? Or have they looked? That was a pretty interesting storm. I looked for aurora, but they say that it was visible in Pennsylvania somewhere. But it was cloudy, hazy, and bright full moon. Well, not full moon, first quarter moon here. So no sightings.
There weren't any chorus events.
But I did hear, oh, actually, this was interesting. My first clue and what got me to check was I was tuning through the WWV frequencies, and 5 megahertz WWV had a warble on it that I know what that means. It was the classic Aurora warble. So there's going to be some interesting stuff in the data.
David, say again when that was.
It was last night. Last night local. Would have been early hours UT. And it hit KF6. Now, of course, the interesting thing there is I'm curious how it is that WWV 5 megahertz, presumably reflecting halfway between here and there, which was not anywhere near the auroral oval, would be getting the auroral warble on it. It must have, the storm must extend to mid-latitude ionosphere.
I'm not sure.
But yeah, given that, that there's especially on the 5 megahertz, there's probably a lot of Doppler shift on that. Maybe enough to just knock it out.
There was chorus emissions detected on Paul's VLF receiver in the UK.
I got a little distracted for a minute because I've been working on this Ionoson project with Bob McGuire, and I don't think I read that paper carefully enough about the size of that antenna. And I'm now getting very worried because it says it's 76 meters on a square, 76 meters per side, and each tower is 100-foot tall. There's 1.5 kilometers of wire, and I'm concerned for a number of reasons because I just measured my field in my backyard, and you know, if it will fit, but the field is basically 76 meters by 76 meters by 76 meters. It's basically 76 meters square. So it will fit, but that will dominate the entire field. And I just don't really think that's a good idea for.
So it
Yeah.
sounds like you're in a search for a new field.
Yeah.
Yes.
I mean, I thought this was, I guess when I first saw this thing, I thought it could be something I could put up more in the woods.
No.
No, it would really, really dominate the entire field. And
Yeah, I know that's because it needs to respond down to 2 megahertz, and you need that size. Now, the thing that we have, I know has been experimented with for sounders is the terminated folded dipole. If you've got enough signal to noise, which, like Yuha was getting it by coding it, and he could get it down to very low powers using coding. And I think he probably was using a folded dipole, which is a manageable antenna. I mean, it's the same size essentially as an 80-meter antenna dipole.
But that
and it will respond down to 2 megahertz, though that gets a little dicey down there, very inefficient. But you could double the size of that and get a reasonably good response.
Yeah, I think there are places I could stick another 80-meter dipole in our woods and you wouldn't really notice it. And but I mean, just to take up our entire field,
yeah, I suspected. I mean, the antennas that I was using were 100-foot tower and then 100 each direction. So it basically, it's a big diamond that's a half of a rhombus.
Yeah.
Half a rhombic pointing up, reflected off of the ground.
Yeah.
And the Lowell antennas, their transmitting antenna is that, and then they use a different receiving antenna. We were using the half rhombic for both transmitting and receiving.
Yeah.
But
Bob Spalletta, do you know any other large fields that the university has access to that we can put a large wire antenna in?
Might be the size of a football field.
Because this is our house. Here's my field right there. And
what about one of your neighbors?
I'd hate to take up their field. I mean,
how long you plan to run this?
Well, I would imagine it'd be at least for a summer, So going from there to there is 88 meters. So, I mean, it will.
Yeah, it would fill your field quite nicely.
Yeah, and then that's 83 meters. So, yeah, it would.
Yeah, they were talking 76-meter spacing between towers.
Yeah, so we could. It'll fit, but I don't think I'm not getting this to measure now.
Now, one thing I've always wondered about is he's got it, going up on 100-foot towers, but you can theoretically pancake it. Basically have a spiral dipole.
A spiral dipole.
Instead, well, he's spiraling up. But you could just reduce it down to a flat spiral.
Yeah.
And might be able to get the response you're looking for.
See, right now we have, we very often sit on the back deck here and look out this way and eat our dinner and appreciate the nice large field. And then we have Jonathan Rizzo's VLF receiver over here in the magnetometer right here, which does okay. And then I have the G5RV Rosetta 6 BKW running along this way. And then I have an 80 meter off center fed dipole running actually from here over to there. So that runs over the house kind of this way. So I have those. So like I was imagining something that was a little less three-dimensional. And I was thinking of for the Anasan putting it kind of in the trees over here, but that clearly is not going to work. There's a quasi clearing over here, which is kind of nice. That would actually potentially be a good place to site something. So, you know, it could go measure. Right, so that's like, you know, that's almost, you can get like 100 meters that way, just about. And that probably wouldn't bother anyone. And then you could still run the coax. It'd be a 400, it'd be like a 400-foot run for the coax going from here to there, which is really far. But possible, I suppose. We do have electric in the barn. It's very, very drafty in there, but I suppose we could work something out where we had some electronics stored down in the barn. And, you know, I don't know if we could, then you could use like trees back here or something, or again, this kind of clearing over here. But I mean, I think, you know, for this project to go kind of the way it would, you'd want to use the whole field, but I just don't think I like that idea.
Does that picture show the trench? That might be too old.
I think it's too old.
Oh.
Yeah.
I see something out in the field.
Well, there's like, we put the, there's stumps out here.
Uh,
There's an old stump and there's some rocks, like there's a rock over there. So we actually put the VLF system kind of by one of these stumps because we figured we weren't going to be mowing that anyway. So, you know, just kind of take advantage of that.
I take it that was cultivated at one time.
I think so. I think this whole area was a farm, and then it's gotten subdivided over time, of course. So
Yeah, in that picture, it's got rows in it.
In this picture?
Yeah. You see how it's got
Yeah.
the rows going back and forth?
Yeah, I don't.
It looks like it was cultivated and then it's been turned into a field.
Yeah. So as far history as I know, before we bought the house, it was rented out to people for maybe like 5 or 10 years. And I don't think the renters did anything with the field that I know of, but I don't really know. Before that, they had horses here. They kept horses in the barn and they would take them out over here.
Mm.
Yeah. So I'm gonna have to, I guess I have to talk to Bob McGuire about what the, yeah, because I don't see that working. We've got this whole like wooded area. All of this is ours, and we can certainly do some things with wires and trees down here and over here. But yeah, I think just putting up 400-foot poles and zigzagging the entire field with wire, I don't think that's going to be desirable. So
Yeah, just the process of putting up even a single 100-foot tower is quite a production.
yeah,
You want to put up 4 of them.
I know.
Wow.
And then having to mow all of this and keep that under control. I just don't see that working.
Do you have to mow that today, Nathaniel?
What do you mean? Do we have to, or do we enjoy mowing?
Oh, you mow it and you don't mind doing it?
Well, Rachel's father views it as a retirement hobby. He has, for a very long time, wanted to own a ride-on lawnmower, and apparently, you know, it just didn't make sense for their their 1 acre lot or half-acre lot in Indiana, Pennsylvania, and this kind of development over there. And so now that we have a lot that actually requires a ride-on lawnmower, when Rachel's parents come down, Rachel's mom enjoys watching Anthony, and her dad enjoys nothing more than just riding around on the lawn tractor back here.
How many acres is that?
It's about 3 acres.
Nathaniel, to answer the two questions that you asked,
Yeah.
the university does have some property out past where you are.
They
Or
used,
actually closer in than you are.
well, they used to. I heard they just sold it though.
Yeah, that's unclear. They never were extremely open about that, because I had a project that needed property, not radio related, and they at first offered it and then didn't. So I don't really know what the status is on the availability of that anymore.
Yeah.
But I thought that we were talking about actually cutting the size of the array a little bit.
What's that?
I thought that we were talking about making it smaller.
Yeah, I'll have to talk to Bob about that, because I think if we can make it smaller, like if I could have it fit in this corner of the field or somewhere on this side, and if we don't have it up there forever, we just we do development project for 1 year or two and we have it over here, that would probably work. But I don't see having it go out. We're not going to be able to put up 100-foot towers and keep them up for indefinite periods of time. Even an entire summer would be a very long time for that.
Yeah, what about that area just past the barn that you were
This part?
Down further away from the house?
Over here?
No, you right now, center of screen, yeah, there.
Yeah.
That corridor there.
Yeah, could that be cleared out a little bit more so that an array the size that you were talking about in the main field could be fit there?
Yeah, we certainly have the length. We're not.
Well, I think that we could also look into
A little bit of a
what the
clearing there.
university has to
So
offer.
what's that?
I think we can also look into what the university has to offer for a temporary
Yeah.
because there are plots of land that they own in various places. That of course is bigger than my entire property. So
Right. Yeah, I mean, we don't mind putting up a few, we certainly don't mind putting up a few antennas here and there. But as I said, I don't think we really don't want to dominate the entire field.
Yeah.
So that's and
I
certainly running.
I was looking at that paper, and indeed that array of that antenna would fill.
Yeah, Nathaniel, that corridor there, that's more than 200 feet end to end, isn't it?
Yeah.
I mean, you could put up the standard Delta, 100-foot tower nestled in the trees. And 200 feet end to end.
Yeah.
That would fit in there.
So So you need a delta, so 200 feet end to end that way, and then what else would you have over here?
Oh, it has 100-foot tower in the middle,
Okay,
and then the antenna, it's terminated at the top, and then
okay,
two sets of wires. It's really a single wire, but it's usually like 3 parallel wires for bandwidth.
Yeah.
2 sets of wires going from the peak down to ground points 100 feet from the tower each direction.
uh-huh,
And then it has essentially a ground referenced transmission line back to the center of the tower. And then you
okay.
have the drive balun at the base of the tower.
Huh.
That's a standard
So
sounder
it would just,
antenna.
so it would just, there'd be a tower here and it would just go out this distance like that.
Right.
Okay. That I think we could do,
That's
you know, that would be doable. That would not, we don't use this area
Yeah.
at all right now. I tried, putting like a walking path through here 2 years ago, but it gets very kind of flooded over here. So it's not really great for walking all the time.
flooded is good for radio work.
This is a very wet area. The town
Yeah.
I live in is called Springbrook. So
Yeah, that would make for a good natural ground plane.
yeah, so I think the property is very good for natural ground plane. Now I would probably be I'd be planning on putting the transmitter up here. So if you put the tower there, that's about a 400-foot run of coax.
Why wouldn't you stick it in the barn?
We could do that. It would cut down the barn. We'd have to fix up the roof of the barn. It gets a little the barn's not totally weatherproof, but but as I
It's a
said,
barn.
it is a barn. The barn is not totally weatherproof, but it does have electricity and it does have some shelter. So if you put it into the right sort of,
Put a box in the barn.
yeah, you
Yeah,
could put a
yeah.
box, yeah, weatherproof box in the barn. Yeah. I'm also looking at the budget that we planned for this antenna and the coax, and I think it might not be as much. Looks like we planned for about, somewhere about, well, I guess this is most. Right here, including antenna and coax and supports. We're looking somewhere a little under $1,000, I think.
Yeah, well, 100-foot tower alone is a lot more than that.
Yeah, I know. So that's going to be, I think we're going to have some discussions about this, but this is.
But you might also just try terminated folded dipole as an initial antenna for experiments, and
Yeah,
it might have an sensitivity.
yeah. Yeah, doing something like this would be much more useful than, or much more, I think, acceptable than taking over the entire field. Interesting.
And can trees be used as masts for HFE field antennas?
I would think so.
Because that's something that I've never tried.
Well, you can certainly suspend antennas from trees. We do it all the time.
Yeah. I mean, that's what I'm doing with my OCF dipoles and my ZS6 BKW.
I mean,
I
if
think
you have, well, I was going to say, if you have some trees that are tall enough, you have basically built-in masts.
Mm-hmm. Yeah. I know we're almost out of time from the normal schedule. Let's see. I think Kung wanted to know, Tom, are you going in person to DCC?
Yes, I am.
Okay, great. Are you planning on presenting there too?
I don't have anything for a paper except a bunch of non-working code.
Okay.
So we'll see how far we get, but right now, no plans for a paper.
Okay. Yeah.
Yeah, I just don't want to repeat anything that you already say in your presentation or mine. So that was my only concern.
Yeah, it's wide open for you. I have nothing planned, so no issues.
Okay, thank you.
That's good. Thank you. I did speak to Scotty last week, so I know he was really swamped with his whole house situation. It sounds slightly more daunting than my antenna situation. And he said that he was going to try to get an adapter board tested this weekend. So I don't know if that happened or not, but we can follow up with him on that.
Well, this is Dave, and I'm gonna say 73. I need to go.
Same here. Jules, we'll see you next week.
Thank you, Jules.
Same
Thanks,
here.
Dave. Yep, I'm
Good
gonna
night.
say
73 is all.
73 as well.
Hey, I'm on QRT as well.
73.
Thanks.
Nathaniel, I'll talk to you in the
73.
morning.
All right, sounds good, Bill. See you in the morning. And Bob, David McGaw over here, he's the engineer from Dartmouth who knows all about the intricate details of designing receivers to study TIDs using clear channel AM broadcast receivers.
Yes, I read the paper, Nathaniel, that you sent me. And have things changed since the I guess that was 2014?
Well, we've done, my internet seems to be screwing up here. No, we've had new work done. We just graduated senior this past year, who did some very nice work with the AM Doppler system.
I was interested in that. I as I said in the beginning of this meeting, I kind of looked at everything and said, I'd like to do all of this. And I do have the one project that Nathaniel and I were just talking about. And this was a project that I was thinking of for my home sort of equipment area. And I was kind of thinking of a lot of similar applications using the fact that I do have a site in Denmark and here, so there's some distance between the two, and maybe looking at signals that traverse the Atlantic. So that was pretty much my my thoughts on that. But as I said, I looked through that paper from, I think it was 2014.
Yeah,
And
that may have been our initial paper on, that would have been Chilcote who did that. But Claire Trope is our student who just graduated. She's now at APL. We finally reestablished contact with her. She was on walkabout, shall we say. But she did some really great work in analyzing the data for TIDs. And yeah, she's presented for HAMSci.
Yeah, but have you changed the hardware at all since the Chilcote paper?
Yeah, Chilcote was done with hardware that we actually were borrowing from Frank Lind. That was part of his ISIS project. It was Ecotech receivers. But all the recent work is using the RTL SDR based receivers that we have now. And so Claire's work was done with the new receivers, which are much more accessible. And in fact, we're in the process of building that system out. It's not fully populated right now. We've turned some of the receivers off. Excuse me. We've turned some of the receivers off for the moment due to internet costs and such. But we're in the process of building some more, and we're looking to have other people install them. Steve Kapler's interested. John Bonnell over on West Coast is interested. So yeah, our local problem is interesting in that our best station went off the air. It turns out the higher frequency stations you want, they're more sensitive than the lower. You get more Doppler shift, obviously. And it's what used to be WQXR in New York City became WFME, and their real estate for the antennas became too valuable, and they sold where the antenna towers were, and now they're trying to get back on the air. But we're looking to see if a Buffalo station can fill in. The idea is that we want to use clear channels so it doesn't muddy the signal. Regionals might be able to work, but clear channels really are desirable. But there aren't a lot of clear channels on the higher end of the AM band, it turns out. They stuck all the locals up there. So it's kind of frustrating from our point of view. There are a fair number in the mid part, in the megahertz, 1100 kilohertz range. But what we considered our primary, which is based in Schenectady, WGME, yeah, something like that. That's where it turns out Phil Erickson's father lives, and that's where the receiver is sited. But that one's down in a lower frequency. I think that's 800 some odd kilohertz.
Yeah, the paper that I read had two frequencies, one around in the 800 range and one near the top of the frequency.
Yeah, I think we were using that one in WBZ Boston.
Yeah.
But yeah, that was the very initial study to see if this was viable. But then we've built out the system to basically 6 receivers around the Northeast. From up here at Dartmouth, we have one over in upstate New York, way upstate New York, Messina. Then Schenectady, what is it, New Bedford, Mass, where UMass Dartmouth is. And then, let's see, we have Jenny Jump, Cornell. I think that's 6 of them. But, we've gotten some good data out of it, but we'd like to spread it, get it spread out so we get a wider range of where the disturbances are.
Well, I am not very spread out from that.
Yeah, of course, the problem with AM stations is that they aren't all very good, well-controlled carriers. So we have to compensate, and hopefully, the idea is to have a receiver near one of transmitters we're using, get a good ground wave reference off of it, and then we subtract that out to get the true Doppler shift.
Yeah, you were talking about that in the paper that I read about that process. Well,
Yeah,
I guess
Nathaniel, when was let's see, when did Claire present at HamSci? It
Like
was
2 years ago, I think.
yeah, I think it was 2 years ago.
Yeah.
It would be in the record, and
I think she
yeah,
presented
I
Hamsite
could.
2020.
What was that?
Hems-
Yeah.
2020.
Yep.
Yeah.
And probably your thesis at this point would be the most recent work.
Yeah, which I have a copy of that, so I
Right.
could send it to.
Yeah,
But
there you go.
I don't think that thesis. I mean, that's all. It doesn't talk about the hardware at all. It just talks about TIDs, right?
Very superficially.
Yeah.
Yeah, the
Right.
hardware I talked about at HamSci some years ago.
Right.
Before that.
Yeah. Here I do have
The hardware hasn't changed since then.
Yeah, that you may have talked about that at the first HamSci.
Yeah.
At NJIT.
Yes, I did. And then yeah, most recently, I guess it was that I gave the talk on the antennas.
Yes.
More generally on everything from the AM Doppler to our auroral work.
Right. Here I have Claire's thesis here.
Yeah, Bob, the primary work we've been doing has actually been picking up auroral radio emissions
okay.
up in the HF range. Primarily harmonics of the ion cyclotron frequency, which is at the upper latitudes and altitudes. It's about 1.5 megahertz is the the electron gyrotron frequency, and harmonics of that just shy of 3 megahertz, 4.5, and 6. You can pick up their energy coupling mechanisms that one can pick up those waves coming down. The interesting thing there is you have to be north of the auroral oval. They don't propagate south, they propagate to the north. So our equipment has been installed at pretty high latitudes, including South Pole, high and low.
That's very interesting, though, the phenomena to pick up. Very interesting. Yeah, that's, as I said, I am really seeing a huge buffet.
Yes, that's a good way of putting it. So if you weren't doing RF, what were you doing all this time?
I kind of moved into coherence spectroscopy, and I was doing radiation chemistry stuff.
Uh-huh.
So I really strongly moved out. I mean, I kept the microwave connection, but really strongly moved out of that area. And so all of my, I was very intrigued by SDRs and things like that. I mean, all of my experience was in actually building local oscillators and stuff like that. So
right.
And,
so you were doing microwave pumping of things, or what?
Yeah, well, I did a lot of communications work, and I did some stuff for the government back in the old days. So that was my background. And then, as I said, I moved into ESR, electron spin resonance work.
Oh, okay.
And that sort of thing. And so I went off very much on that tangent and didn't really touch any RF until other than, you know, stimulation of flips on the nucleus.
Yep.
Other than that, I didn't.
I tried to make an ESR experiment back in high school. I didn't really get the signal out of it, but there was a article in the Amateur Scientist in Scientific American on how to build a rudimentary ESR.
Yeah, the thing is that if you have anything, if you have a strong magnet and something, a klystron, and a very, very strong signal.
Yeah, well, this was low enough magnetic field that you could resonate it at the at HF. I
Okay,
forget
yeah.
what frequency they had us working at, but it
Well,
wasn't microwave. It was very low frequency.
Yeah, so then you were at a lower magnetic field.
Right.
Yeah. So you were probably in a strong permanent magnet range.
Exactly. That's what it was. Used
Yeah.
a strong permanent magnet with some soft iron pole pieces.
Yeah.
Stuck a bunch of water in the middle of it with a coil around it and resonate it and see if you can. It was basically a grid dip meter stuck between in a magnet.
I was, as a matter of fact, you remember, Nathaniel, when you were doing that space camp thing, and you had those meters, I was thinking about the old days and the grid dip meter that I had as my prized possession.
Yeah. Yeah.
Yeah, so that's my experience is all way back then.
Uh-huh. Well, I still play with tubes.
Yeah, I think I was telling Nathaniel that I was the last class as an undergraduate to be taught tubes.
Uh-huh.
They switched over to solid state.
Right.
To the transistors and H parameters. I'll never forget the introduction to H parameters and the transistor.
Mm-hmm.
But klystrons were still around for a long time.
Still are.
Yeah, in your microwave.
Mm-hmm. Yeah, well, yeah, that was one of the things that we had equipment up in Greenland at the Sonderstrom ionospheric research facility. They had a big klystron. That was at 1296 megahertz. I forget, it was 1 to 2 megawatts for their transmitter. I watched them change out the tube one time I was up there.
Yeah, at that frequency, it's big.
Yeah, that's a big guy.
Yeah.
And unfortunately, when they got the new one swapped in, they didn't tie one of the cooling hoses down properly. And all of a sudden, there was a strange noise coming from the next room as we were having dinner. It's like, that's not supposed to sound like that. There was coolant spraying everywhere.
That's not good. I think I'm gonna dip off here. I'm gonna go try and write a little more code before I head to bed. So,
well,
I should probably go too. It was great talking to you.
Yeah. Welcome to the project.
Thank you.
As you say, it's quite a smorgasbord.
Yes.
It certainly is. Thanks, Bob. Thanks, David. Thanks, Jonathan.
Thanks all. 73.
73.